Rocks loafing about on the surface of Mars have been harboring secrets about the red planet's mysterious past. The mineral content of oddly pale rocks found in Jezero crater can only have formed under very warm, very soggy conditions, suggesting that, long ago, Mars may have been a lot more peculiar than we ever suspected. On Earth, these minerals form where there's intense rainfall and a warm climate, or in hydrothermal systems, such as hot springs. Both environments are ideal conditions for life as we know it, says planetary scientist Roger Wiens of Purdue University in the U.S. These minerals are what's left behind when rock has been in flowing water for eons. Over time, the warm water leaches away all the elements except those that are really insoluble, leaving behind what we found on Mars. It's fascinating. It's unexpected on a cold, dry planet like Mars. What Mars looked like in the early eons after its formation and how it has changed over the years are mysteries planetary scientists are intent on solving. Not least because the answers could tell us whether the red planet has ever been hospitable to the emergence of life as we know it. The history of Mars is written in its rocks, and Earth has taught us the language to understand it. The trick is to identify salient Mars rocks and find the information to decode. No small task from millions of miles away. NASA's Mars rovers, Curiosity and Perseverance, are designed to perform this function as our proxy, with human scientists here on Earth operating the robots remotely. The rocks in this discovery were discovered by Perseverance in Jezero crater, standing out as oddly pale, just sitting on the surface of Mars, incongruous with their surroundings. Rocks like these are known as float rocks because they float above the bedrock, having been transported from their original location by processes such as weathering, erosion, or water to somewhere new. Scientists had spotted these float rocks hanging around in Jezero crater from Perseverance's very first day of operations, but hadn't taken time to really look at them until they did. They directed Perseverance to use its laser-induced breakdown spectroscopy instrument. This is a tool that fires a laser pulse at a mineral. That laser pulse vaporizes a small amount of the mineral and excites it. The spectroscopy instrument then studies the light emitted by the atoms and ions of the mineral vapor as they return to their ground state, to see what elements those atoms and ions are. The results were a huge surprise. These rocks are very different from anything we've seen on Mars before. Wiens says they're enigmas. The main composition of the rocks is a mineral called kaolinite, a soft, white silicate clay mineral. The Martian kaolinite is slightly different from terrestrial kaolinite. It's significantly harder, perhaps as a result of different weathering conditions on Mars. Kaolinite requires temperate, wet conditions to form. Conditions that are hospitable to some forms of microbial life. With over 4,000 of the rocks spotted in Jezero crater, this makes the discovery particularly exciting. The researchers also identified a mineral called spinel. Here on Earth, spinel is a magnesium aluminum gemstone. How the spinel got into the kaolinite rocks is unknown, but the researchers believe it is an aluminum-rich type that can form in both igneous and metamorphic environments. It's also unclear where the kaolinite came from. Satellite images show kaolinite-rich rocks in the rim of Jezero crater. If scientists can work out where the rocks formed, they can get a better idea of how they formed. That information may also reveal vital clues about the water history of Mars and its past habitability. The big questions about Mars are about water. Wiens says, how much water was there? How long was there water? Given how cold and dry Mars is now, where did all that water go as a mineral? Kaolinite has a lot of water bound up in its structure. It's possible that a lot of the water is still there on Mars, bound up in the minerals,